Hello and welcome everyone. Welcome to Gate Wallah English channel. Let us start today's session. I think my voice and video is clear. So please confirm everyone if everyone can listen my voice, everyone can watch this lecture properly. Okay. So again, we are going to discuss 10 very important questions of communication system. Okay. Fine. Okay. Please everyone join this session as soon as possible so that we can start this session. 10 very important questions we are going to discuss from the communication system. This will include questions from random variable, random process. This will include questions from the probability of error. This will include the questions from power spectral density. Every topic we will try to cover in this class. Okay. Perfect. So let us start first question first of all. In this question, okay, let us start the question. So for this question, let us read this question, what is given. In this question, in a communication system, a symbol S1 equal to +2 and S2 equal to -2 are sent over channel. Channel is noisy and noise PDF is given below like this. Okay, so this is the noise PDF and probability of S1 is given as 1/3. Okay, noise is additive in nature. If optimum receiver with threshold value x equal to 1 is used at the receiver, then probability of error will be. So as every one of you know, in these type of questions, what should we do? First of all, we should make the optimum basically decision device. Okay. So as soon as you will be making the decision device, this is the decision device that we are making. Fine. Perfect. Perfect. So this is the decision device. What is the input of the decision device? It is always a conditional random variable. Okay. In this case, the conditional random variable is mentioned as s plus n. And threshold value is given as x. This is the decision device, and obviously this is y cap. Okay, so this y is conditional random variable, so you can write it like this. Value of s is +2, so this will become -2 plus n when 0 is transmitted, and it is 2 plus n when 1 is transmitted. Okay, so we have made this expression y is equal to s plus n, which is mentioned here. Fine. So in case of calculation of the probability, when your threshold value is mentioned to us, first of all, we should make the conditional PDFs. Okay. So first of all, I will make this PDF and this PDF. Fine. This is the PDF of y. PDF of y, and I'll be writing the name y 0 transmitted y. This will be the conditional PDF of y 1 transmitted y. Okay. If the PDF of n is mentioned, which is from -2 to 2, what is the PDF of -2 plus n? So this PDF will be shifted leftwards by -2 unit. Okay. So this will be shifted leftwards by -2 units. So this becomes like this, and this PDF will be shifted rightwards by 2 units. Okay. So overall, this value becomes 0, -4, this becomes 1/4. This value becomes 0, 4, and this becomes 1/4. Perfect. As you can see, in this case, the threshold value is mentioned as 1. So I'll be drawing a threshold like this, lambda equal to 1. Okay. You know that you have to calculate the area after this, because this is corresponding to the 0 transmission, and you have to calculate area behind this. What is this area if this value is 1? Okay, this area is 1/4. And what is the probability of 1 transmission? It is 1/3. So the probability of error in this case comes out to be 1/12. Okay, so I hope this is a very simple question. Everyone is able to solve this question. Fine. Perfect. So in this case, as you can everyone see that they were asking the probability of error for this value of lambda equal to 1. Fine. Very, very simple question. Okay. Now let's move on to the next question. Next question. Fine. Try to read this next question. In this question, they are saying that wide sense stationary random process x of t is sampled at the instances t1 and t2. So when you are sampling a random variable at instances t1 and t2, you know that you will be getting the random variables. Any random process, if it is being sampled at different time instances, you are bound to get the random variables. Now they are asking that xt1 and xt2 has mean mu1 and mu2, and variances are sigma 1 square and sigma 2 square. You know that in case of wide sense stationary random process, Whites and stationary random process, suppose if you are having a random process x of t, okay, and this x of t, if suppose it is being sampled at t equal to t1, so this becomes x t1. At t equal to t2, so you will be getting x t2. Okay, this is the random process, and if it is being sampled, it becomes random variable. So you know that what is the property of the WSSRP? The property of the WSSRP is that if you are calculating the mean of this random process or the mean of any of these random variables, all of them will be equal. Secondly, if you are calculating variance of this random process, this will always be equal to the variance of this random variables. So we can simply say that this value of mu1 will be mu2 and the value of sigma 1 square will be sigma 2 square. You can simply write it as ki this will become expectation of xt. Random process mean will always be equal to the means of the random variable. In that case also, variance of the random process will always be equal to the variance of the random variables. So in this case, A option has to be correct. Fine. So in this case, A option has to be correct for this case. Okay, so we have solved two questions. One question was from probability of error and random variable. Another question is from random process. Okay, now let's move on to the next question. In this question, again, this is the question of the random process. Again, they are saying that a WSSRP x of t has power 20 and mean 0. Okay, so this means the power is mentioned there. Now, two other random processes are defined as this wt and yt. They are asking the summation of the power content of wt and power content of yt. Okay, so they are asking us to calculate the summation of the power of these two. Fine. So what is the data which is given to you? The data which is given to you is x of t is the random process. Okay, now the mean of this random process will be 0 and the power of this random process, which means you can write it like this: expectation of x square t is equal to r x of 0 equal to 20. Fine. This is something which is mentioned to you. Perfect. Now we have to calculate the power of this random process. Wt is equal to 2 times x of minus 2t plus 3. Okay, this is something which is given to you. Now, if you want to calculate the power of this random process, you know that you simply have to do the square of this, which means this will become expectation of 4x square minus 2t plus 3. Fine. I can take this value as 4. Now, you know that since this is WSSRP, so the mean or the mean square value or the variance is independent of t. You can put any value instead of t. The mean will remain the 0 and the mean square value or the variance will remain the 0. So what is the value of this expectation of x square minus 2t plus 3? I can put anything instead of this t. The value of expectation of x square minus 2t plus 3 has to be 20. So this will become 80. Okay, now let us solve the second. 4x of this was your wt. Now yt was also mentioned. Yt was mentioned as 4x of t by 2 plus 4. This is mentioned. So if you want to calculate expectation of y square t, this will become expectation of 16 x square t by 2 plus 4. Okay, I can take this 16 outside and inside this will become x square t by 2 plus 4. Now this value becomes 16 into 20. Because I can put anything instead of t, the value has to be 20. So this becomes 320. Okay, so what is the answer of this question? Answer of this question becomes 80 plus 320, which means the answer has to be 400. Answer has to be 400. Okay, this answer has to be 400 in this case. Perfect. Now let us solve the next question. In this question, again, WSS, White's stationary random process, xt is passed through the system. This is the xt, we are passing it through the system. This is wt. The autocorrelation function is mentioned as 4e to the power minus tau square. Okay. Now again, we are defining a new system in the form of the input output relationship. Y1t is equal to 2x12t plus 3x12t plus 1. Then power content of random process. So they are asking the power content of this random process. Is it fine? Perfect. Perfect. Okay. Now we have to calculate the power content of this process. How will you calculate the power content of this process? There are two methods in which you can calculate it. First method, simply you can calculate the autocorrelation function of this. Okay. And once you'll be calculating the autocorrelation function of this, simply put tau equal to 0. Done. Perfect. So this is xt and yt. So yt is mentioned as 2 times x of 2t plus 3 times x of 2t plus 1. Okay. So instead of this, I can write it as yt into y of t plus tau, because you know that this will be autocorrelation function. Okay. Perfect. So I can write it as 2x 2t plus 3x 2t plus 1. Now I can also write it like this, 2x 2, instead of t I'll be writing 2t plus tau plus 3x 2t plus 2 tau plus 1. Okay. Now let us try to multiply this expression. So this becomes 4 x of 2t x of 2t plus 2 tau plus 6 x of 2t x of 2t plus 2 tau plus 1 plus 6 x of 2t plus 1 x of 2t plus 2 tau plus 9 x of 2t plus 1 x of 2t plus 1 plus 2 tau. Okay. So you know that the first expression becomes 4 times r x of 2 tau. Second becomes 6 times r x of 2 tau plus 1. Third becomes 6 times r x of 2 tau minus 1. And last one becomes 9 times r x of 2 tau. Okay. Since we want to calculate the power of this output random process, instead of tau I'll be putting it 0. So once I'll be putting it 0, this becomes 4 times r x of 0. 4 and 9 I can add, so this becomes simply 13 times r x 0 plus 6 times r x 1 plus 6 times r x minus 1. Okay. So this is something which is mentioned to us. Now we have to calculate this value. This is 13. This is 13. Okay. Clear everyone? Now in this question, r x of tau is mentioned as 4e to the power minus tau square. You need the values of r x of 0, r x of 1 and r x of minus 1. So why should we not calculate the value directly from here? So once we'll be calculating the value from here, you can get r x0 as 4. You will be getting r x1 as 4. You will be getting r x minus 1. This will be 4 e inverse and this will become 4e. Okay. Instead of basically both will become e inverse, because this is tau square. Instead of tau, if you will be putting 1, this will become e inverse. If you will be putting minus 1 square, this becomes e inverse. Correct? Now let us put all the values here and you will be getting the answer. So this becomes 13. Okay. Plus 4 tha 4, 24 e inverse plus 24 e inverse. So basically this becomes 13 plus 48 e inverse. Okay. Solve this value in the calci, you will be getting the final answer. Okay. So let me also calculate. We will be getting this expression as 69.65. Okay, 13 into 4 na? So this will become 52. Instead of 13 you should write 52. Okay, and what will be the final answer? This will be 69.65 roughly. Okay, so answer of this question is 69.65. Whatever may be the unit you want to assume. Done? Perfect. Now let us move on to the next question. So in this question, perfect. In this question, two WSS random processes, XT and WT, are uncorrelated. So they are saying uncorrelated, which means their covariances has to be 0. Uncorrelated means their covariances will always be 0. Fine. Now, power spectral density of the processes XT and WT is shown below. Okay, so this is the power spectral density. I'll highlight it a little bit. So this is the power spectral density. Okay, this is the power spectral density. Perfect. And there is impulse also present at t equal to 0. Fine. This is the impulse that we are getting. 0. Fine. Perfect. Now they are asking us to calculate the variance of this random process ZT. ZT is equal to 2 times XT HT. HT is del t minus 2. So ZT from here becomes 2 XT convolution HT. So this becomes 2 times capital X of t minus 2 plus W minus 2t. Okay, they are asking us to calculate the variance of this expression. So I have given you the shortcut to calculate the variance. Z square t, you can simply write 4 times x square t minus 2 plus W square minus 2t plus 4 x of t minus 2 W of minus 2t. Okay, so if I want to write the variance of this expression, this will become 4 times sigma square x of t minus 2 plus sigma square W of minus 2t plus 4 times covariance of x of t minus 2 W of minus 2t. Okay, so since you are calculating the covariance of this complete expression, so overall this value becomes 0. Why? Because it is mentioned that xt and wt are uncorrelated random variables. If they are uncorrelated random processes, so their covariance has to be 0. Now simply you have to calculate the value of the variance. How can you calculate the value of the variance? Suppose if I want to calculate the value of the variance, this will become sigma square is equal to expectation of x square minus expectation of x whole square. You know that in case of PSD, if there is no impulse at this origin, which means the expectation of x becomes 0. How to calculate expectation of x square, which means power? So simply you can calculate the area of this curve because it is given in f domain. If it would have been given in omega domain, you can simply calculate the area and divide it by 2 pi. So this value comes out to be 16. Perfect. From here, what should be the value of sigma W square? This becomes expectation of W square minus expectation of W whole square. What is the mean of this? So you know that if impulse is present at origin, so the mean becomes the area of the impulse itself. Okay, so if you want to calculate the expectation of W square, this becomes 0 minus 0 plus SWF df. Okay, so directly this value becomes minus 6. What is the value of expectation of W square? For that you need to calculate the complete area. What is the complete area? This is half, base is mentioned as 8, height is mentioned as 4 plus 6. So this becomes 16 plus 6, which means 22. So 22 when subtracted from 6, you will get it as 16. Okay, everyone. So for this question, the answer that you will be getting it as, you will be getting the value as 4 into sigma x square we have calculated as 16 plus this value becomes 22. Okay, so this comes out to be 64 plus 22, which means 86. So for this question, the answer would have been 86. Done? I think yes. So very, very simple questions. You can very easily solve all these questions if you have studied random variable properly. Okay, fine. Now in this question, it is given that which one of the following cannot be the autocorrelation function of a random process? Cannot be, they are asking. Okay, so can you tell me what properties do we need to check if we want to validate a random process? In case we want to validate the random process, what are the properties that we need to check? So if you want to validate the autocorrelation function, so we basically have to validate two possible values. First of all, that the value of the autocorrelation function has to be maximum at tau equal to 0. Secondly, the graph of autocorrelation function has to be even in nature. Okay, so it has to be even in nature. Fine. Now, in all the possible options, we know the graph of the sink. This is even as well as, and at tau equal to 0, this will be maximum. So this can be a valid graph of a PSD. For this graph, we also know that value is maximum at tau equal to 0, and this is also even, so this will be also be a valid graph. For this case, you can see that the maximum value is occurring at tau equal to 0, which is 1.2. Secondly, this graph is also even, so this is also a valid. So obviously only one option is left, C. This cannot be a valid graph of PSD. More than that, you can simply plot it. It is asking us to calculate 1 minus tau 1 plus mod tau. Okay, so we can plot this value. How the graph looks like: for tau greater than 1, it has to be 1 plus tau. For tau less than 1, which means minus 1 to 1, it has to be 1 minus mod t. Minus 1 to 1. 1 minus mod tau for mod tau less than 1. So this becomes 1 minus mod tau when tau is from minus 1 to 1. Okay, when tau is from minus 1 to 1. So this is something which you have to plot. How the 1 minus mod tau will look like? 1 minus mod tau looks like this, a triangle. Okay, from minus 1 to 1. Now 1 plus mod tau for mod tau greater than 1, which means tau greater than 1, and 1 plus mod tau for tau less than 1. So this can be opened as 1 plus mod tau for tau greater than 1, which means 1 plus tau, basically because tau is positive in this case. So 1 plus tau, this value will become 1. At tau equal to 1, this simply jumps to 2. Okay, and after that it becomes a linear graph like this. Fine. So this is the graph that you will be getting. What about tau less than 1? For tau less than 1, this will become 1 plus tau. Okay, so tau less than 1, 1 plus tau, and for tau less than minus 1, again this graph is we can also break it into two parts: 1 plus tau when tau is between 0 to 1, and 1 minus tau when tau is less than minus 1. So minus 1, okay, this, but another extra part will come between 0 to 1, which is again 1 plus tau, which means this becomes 2 plus 2 tau. So this graph between 0 to 1, again this graph comes back like this. Okay, so overall this graph becomes a non-even graph. Moreover, this value is also not maximized at tau equal to 0. So this option has to be, this is the correct option, but obviously in this case, for this graph which is mentioned in the C part, this is not a valid autocorrelation function, because first of all it is neither even, secondly this graph is also not maximized at tau equal to maybe 0, because you can see that if I'll be putting tau equal to 1000 and tau equal to 0, so at tau equal to 0 you will be getting the value as 1, but at tau equal to 1000 you will be getting the values which is very greater than 1. Okay, perfect. Now let us move on to this question. Okay, in the next question they are asking us to calculate x and y are two independent and identically distributed random variables with probabilities x equal to 0, x equal to 1, x equal to -1, and respectively determine the entropy of x plus y. Okay, so we'll be assuming another random variable z as x plus y. So what are the values this random variable can take? Both x and y are identically distributed random variables, so both can be -1. Okay, both can be -1. So this value becomes -2, -1, 0, 1, 2. Okay, so we have to calculate these probabilities. What will be probability of z equal to -2? This is x equal to -1 intersection y equal to -1. Fine. And obviously, since independent random variables are there, you can simply multiply both of them. Intersection converts into multiplication. Okay, so this value becomes 0.3. No, 0.5 into 0.5. This is 0.25. Now another random variable becomes z equal to -1. Probability of x equal to -1 intersection y equal to 0, or the probability of x equal to 0 intersection y equal to -1. Fine. So this becomes probability of x equal to -1, probability of y equal to 0, plus probability of x equal to 0 into probability of y equal to -1. Probability of x equal to -1 comes out to be 0.5. Because multiply we have to do 0.5 with probability of 0, which is 0.3. So this is 0.5 into 0.3 plus 0.5 into 0.3. So this value overall becomes 0.30. Similarly, you can calculate the remaining values also. We will calculate the probability of z equal to 0. How will you calculate the probability of z equal to 0? In this case, x can be -1 and y can be 1. Fine. Plus probability that x is 1, y is -1, or finally both of them are 0. Both of them are 0. Okay. Any other possibility for z equal to 0? No, only these three possibilities: -2 plus 2, -1 plus 1, and both of them are 0. Simply multiply all the probabilities. So the probability of z equal to 0 becomes probability of x equal to -1, y equal to 1, plus probability of x equal to 0, y equal to 0, plus probability of x equal to 1, y equal to -1. Okay, so again let us calculate all the values. 1 and -1 probabilities we need, and it is 0.2, 0.5. Okay, so this becomes 0.2 into 0.5 plus probability of x equal to 0 is 0.3. So this becomes 0.3 into 0.3 plus 0.2 into 0.5. Now if I'll be calculating all the values, 0.10, 0.09 plus 0.10. So this becomes 0.29. Okay. Similarly, we have to calculate the probability of z equal to 1. How will you calculate the probability of z equal to 1? X becomes 0, y becomes 1, plus y becomes 0 and x becomes 1. Again, these are independent random variables, so you can simply multiply their values. Probability of x equal to 0 into probability of y equal to 1 plus probability of y equal to 0 into probability of x equal to 1. Okay, so once you'll be calculating this value should come out to be, put all the values, and this comes out to be 0.2 into 0.3. Okay, 0.2 into 0.3, 0 or 1, yes, plus 0.2 into 0.3. So this becomes 0.12, 0.06, 0.06, 0.12. Finally, you can calculate this value as probability of z equal to 2. When will be z equal to 2? Only when x is 1, intersection y is 1. Now this becomes x equal to 1 into y equal to 1. So x equal to 1 is 0.2, y equal to 1. So this becomes 0.04. So you have calculated all the possible values of z, also their probabilities. Now you have to calculate this entropy. Okay, their entropy. Entropy is nothing but minus summation of zi probability z equal to zi. Okay, you can put all the possible values. Zi means what are the values taken by zi. Sorry, what I have written, probability that z equal to zi log base 2 probability that z equal to zi. Okay, so we simply have to calculate the probabilities. First was 0.25 minus 0.25 log base 2 0.25 plus the next probability is 0.30, 0.30 log base 2 0.30 plus next 0.29, 0.29 log base 2 0.29 plus 0.12, 0.04, 0.12 log base 2 0.12 plus 0.04 log base 2 0.04. Okay, so this you have to calculate. So the entropy of this question comes out to be, I have the calculation, 2.09 bits per symbol. 2.09 bits per symbol. Average amount of information represented by this entropy is 2.09. Clear? Everyone? Perfect. Now let us move on to this question. In this question, they are asking that these type of the signals, these signals are applied to a matched filter. Okay, to a matched filter with input noise is white noise having PSD eta by 2 दे रखा है. Which of the following waveforms have signal to noise ratio equal? How to calculate the signal to noise ratio in case of matched filter? First of all, this is the signal to noise ratio at the sampling instant. So what is the signal to noise ratio at the sampling instant? You know the formula, signal to noise ratio at output of matched filter at sampling instant. Okay, so this is the signal to noise ratio. Fine. So if I want to calculate the signal to noise ratio, this is the energy of the input pulse divided by N0 by 2. What is the energy of the input pulse? You can calculate the energy of this pulse, 4 square by 3 into 4, 64 by 3. How to calculate the energy of a triangular pulse? A square by 3 multiplied by duration. What is the energy of this signal? 2 by root 3 square multiplied by 16. This also becomes 64 by 3. What is the energy of this sinusoidal pulse? 4 square by 2 into 8 by 3. This also comes out to be 64 by 3. What is the energy of this pulse? This becomes A square 16 by 3 into 4 plus 16 by 3 into 4. Okay, so this becomes 128 by 3. So there the fourth option has the different energy, but S12, S2T, S3T has the same energy. So which option has to be correct in this case? S1T, S2T and S4T. So A option has to be correct. Okay. MCQ question was this. This could have been very easily converted into an MSQ question. Okay, just by framing the language of this question. By framing the language of this question, you can simply convert it into MSQ also. Fine. Perfect. Now let us read this question out. In this question, they are asking us, I think options are given in the next page. Yes. They are asking us, in the on-off keying version of an ASK system, symbol 1 is represented by transmitting a sinusoidal pulse. Absolutely. And EB is the energy of the signal per bit and TB is the bit duration. Symbol 0 is represented by switching off. This I have already told you that while transmitting the symbol 0, what we do not transmit anything at all. Okay. Assume that symbols 1 and 0 occurs with equal probability. For an AWGN channel, determine the average probability of error for this ASK system with matched filtering scenario. So we already know that what is the formula of the probability of error in this case. The formula of error for ASK comes out to be Q of under root A square TB by 4 N naught. Okay. So this value becomes, what is the bit energy? ये होगा A square TB by 2. So this becomes EB by 2 N naught. Okay. Very, very simple question. So, but this EB, you need to remember, this is the bit energy. Okay. Sometimes options are given in form of average bit energy. So remember this thing, if you want to calculate the average bit energy, so this becomes A square TB by 4, basically A square TB by 2 and multiplied by the probability of the one transmission. So this is the average bit energy, but they are asking the information about bit energy. So which option has to be correct? C option has to be correct. Okay. Perfect. Communication system Maha revision will be on 28th of January. Okay, 28th of January, we will be doing the Maha revision of communication system. All the formulas, all the important points we will discuss there. Fine. Now let us move on to the next question. This is the next question. In a binary symmetric channel, the input symbols are assigned probability as this binary symmetric channel. First of all, I'll make it. Okay, I'll make this binary symmetric channel for you. This is the binary symmetric channel. So the binary symmetric channel input symbols are assigned probability as 1. So this is 0, this is 1. The probability for this 0 comes out to be 0.3 and probability for this 1 comes out to be 0.7. Fine. The crossover probability is mentioned as 1 by 4. So this is 1 by 4, 1 by 4. So this value becomes 3 by 4, 3 by 4. Now they are asking us to calculate if the received bit is 0. What is the probability that 1 was transmitted? So they are asking us to calculate this. Okay. If I designate this as x0, x0, x1 and y0, y1. Okay. So this you can simply calculate it as y0 by x1 into probability of x1 divided by probability of y0. y0 by x1 is the crossover probability. What is the probability of x1? This is 0.7. How will you calculate the probability of y0? So simply stand here and calculate all the path probabilities. 0.3 into 3 by 4. So this is 0.3 into 3 by 4 plus 0.7 into 1 by 4. Okay, calculate this value. You will be getting the answer for this question. Okay. So the answer for this question after calculation should come out to be 0.4375. 0.4375. Okay. Numerical answer type question from the binary symmetric channel concept. 0.4375, you should be getting this value. Okay, everyone. Should we move on to the next question? Perfect. Now let us move on to this question. Okay. In this question, a stationary random process has an autocorrelation function given by this. Okay, so this is the autocorrelation function of a stationary random process already mentioned to us. And it is known that random process never exceeds 12 in magnitude. Fine. Assuming A is equal to 12. Okay, so this value of A is mentioned as 12. How many quantization levels are required to guarantee SQNR of at least 70 dB? Okay, so they're asking us how many quantization levels are required to guarantee a SQNR of at least 70 dB. So what is the formula of the SQNR? SQNR becomes B log base 2 1 plus S by N, or maybe simply if you want to write it as, we can write it as signal power by quantization noise power. Okay, they were asking about the SQNR, not signal to noise ratio. Okay, so this becomes this. How to calculate the signal power? You can simply calculate the signal power as expectation of x square t is equal to Rx of 0. Rx of 0 becomes a square by 2, which means 12 square by 2, which means 72. So this value becomes 72, and this is delta square by 12 equal to SQNR is mentioned as 70 dB. So SQNR in dB, which means 10 log equal to 70. So SQNR comes out to be 10 to the power 7. Let me put the value here, 10 to the power 7. From here you can calculate the value of delta. Once you'll be calculating the value of delta, this delta comes out to be 9.29 into 10 to the power minus 3. 9.29 into 10 to the power minus 3. Okay, this is the value of delta that you should get it from here. Perfect. So how to calculate quantization levels from here? You know that delta is equal to 2 times the maximum value divided by L. It is already mentioned as whatever may that this random process, it is achieving never exceeds, which means it is having the highest value as 12. Okay, so this value becomes 2 into 12, which means 14. So value of L becomes 24 by 9.29 into 10 to the power minus 3. Okay, approximately the value of L comes out to be 2583.42. 2583.42. So this is the quantization levels that we need. Approximately this is the quantization level that we are getting. Okay, you can also calculate the number of bits per sample. Fine. So I have solved 10 very important questions from the different topics. For example, probability of error, random process. I hope you will be watching this lecture, and the PDF will also be available on the PW app. You can go through it and you can solve each and every possible question, and let me know in the comment section whether you like the lecture or not. So we'll be giving you more number of lectures, more number of content on this channel very soon. Thank you so much, everyone.